can you think of whole number solutions to this equation here? And you're not allowed to use the same value for A and B because that would just be cheating. Now, have you thought of any? Well, if you made A 2 and B 4, or the other way around, then you end up with 2 to the power of 4 is equal to 4 to the power of 2. Now, 2 to the power of 4 is 16, and 4 squared, 4 to the power of 2, is also 16. So that works. But what's remarkable is that these values for A and B are the only whole number solutions to this equation where A is not allowed to be equal to B. And how can we prove that? Well, we have to use something called logs for this. And what logs do is find unknown powers. So for example, if I had 2 to the power of x is equal to 9, and we wanted to find the value of x, we would use log for that. So we'd say that x is equal to log base 2 of 9. And you can find the log key on your calculator. Now, we typically use logs when we want to solve an equation where the variable is in the power. So let's log both sides of the equation. And I'm actually going to use something called natural log, which I won't go into now. But if we do the natural log of both sides, which we write as ln, then there's a law of logs that allows us to move the power to the front of the log. So we end up with b ln a is equal to a ln b. And then if we divide appropriately, we get ln a over a is equal to ln b over b. Now, can you see we have the same expression on the left-hand side and the right-hand side, except that instead of a here, we've got b here. So let's define a function, f of x is equal to ln of x over x, because that means that this equation could be written as f of a is equal to f of b. So that's basically saying that for two different values, a and b, the output of this function, the output f of a and the output f of b, is the same for both of those values. Now here's a sketch of y equals that function where the function is ln of x over x. And we said we wanted to find two values a and b such that f of a is equal to f of b. Now since y is the output of the function, what we're basically saying is that we want the y value here to be the same as the y value here. So suppose the input of the function was a here, then this y value here is f of a. But we said for some b, the y value is the same. And we can see it's over here. If we choose b to be this value of x here, we can see these have the same output, the same y value. Now, can you see that if I choose a value of x between here and here, then when I choose that value of a and then find another value of x, which gives you the same y value, you can see there's only going to be one value for b that would give you the same y value. Now, the value of e is roughly 2.71. And we said that we're choosing a value of a that's between 1 and this value here, which is roughly 2.71. But the trouble is, there's only one value of a we could pick between 1 and 2.71, which is a whole number. And that value is 2. And that basically proves that there's only one value of a that we can pick. A has to be 2. And if a was 2, then we can work out that the b would have to be 4. And that gives you the only solution to this equation.